Hello viewers, welcome to my channel. Second matter, the solution to your math problems. Still on trig, angle of depression. Question number 4. I read, from a lighthouse, the angles of depression of two ships on opposite side of the lighthouse were observed to be 30 degrees and 45 degrees. So let's analyze the first statement. So we have a lighthouse. So obviously the lighthouse is built inside the sea. So let's first of all represent that. So we have our sea level. So we have our sea level. This line here represents our sea level. And then we have a lighthouse. So obviously the lighthouse is built inside the sea. And then we have two ships on the opposite side of the lighthouse. So meaning that one ship if one ship is located at this point, then the opposite side will be this side. The other ship will be located at this point. Okay, so these are our two ships located at the opposite side of the lighthouse. And again, you could see that the lighthouse will meet the sea level at an angle of 90 degrees. So that is what we have done. And then we were told that from the lighthouse, so being that from the top of the lighthouse, when we measure the angle of depression of these two ships, that should give us 30 degrees and 45 degrees. So let's do that. So if you remember at the introductory part, we said that before we measure the angle of a depression, there must be a horizontal line of sight. So this is our horizontal line of sight, and then the angle below the horizontal line of sight becomes the angle of depression. So then the angle below so where do we place the angle of depression? So now for the first ship, the angle of depression is 30 degrees. So the angle below the horizontal line of sight, and then the angle of depression of the second ship measures 45 degrees. So that is what we have done. Now I continue. If the height of the lighthouse is 90 meters, so the height of the lighthouse is measured above sea level. So this height here from this point to this point measures 90 meters. So it measures 90 meters. That is what I've done. And then the line joining the two ships passes through the foot of the lighthouse. So that is the line. You have to find the distance between the two ships. You have to find the distance between the two ships. So we are looking for this distance between the two ships. So let's label our diagram. So I'll label this ship as, let's say, ship A. So let me label this point here as B, C, and D. So we have labeled our diagram. So now I'm also representing the distance from A to B. The distance from A to B as X, and then the distance from B to C as Y, so that our calculation will be made easier. Now again, when you observe very closely, you could see that we have two right angle triangles, the one on the left and then the one on the right. So before we calculate the distance we need to get an acute angle inside the right angle triangle. So when we recall from angle properties of parallel lines, we know that alternating angles are equal. Alternating angles are angles that are formed from the alphabet Z. So if this angle here measures 30 degrees, then obviously this angle here must also measure 30 degrees. And again, if this angle here measures 45 degrees, because alternating angles are equal, this angle here must also measure 45 degrees. So now, starting with the first right angle triangle. So how do we label it? So I'm labeling the first right angle triangle as triangle ABD. Triangle ABD. That is for the first right angle triangle. And then for the second right angle triangle, I'm labeling it as triangle BCD. Triangle BCD. So that is for the second right angle triangle. So now, using the first right angle triangle, let's calculate the distance between point A and point B. Let's calculate the distance between point A and point B. So before we do that, we need to identify the sides of the right angle triangle. So now let's identify the sides of the right angle triangle ABD. So this side here represents the hypotenuse because it is the longest side. As you can see, it is the longest side. So that is the longest side. Again, it is the side facing the 90 degrees angle. And then we know that angle on a straight line sum up to 180 degrees. So if this angle here measures 90 degrees, then automatically this angle here must also measure 90 degrees. So that makes line AD the hypotenuse. Again, this side here, the height of the lighthouse represents the opposite because the height of the lighthouse faces the acute angle. That makes it opposite. And obviously, the remaining side here becomes the adjacent. The remaining side becomes the adjacent. So we are looking for this distance here. And then we know our opposite. So we know our opposite. And then we want the adjacent. So from SOHCAHTOA, which of them has opposite adjacent? So that is TOA. So what does TOA says? So from the first right angle triangle, from triangle ABD, from triangle ABD, from triangle ABD, from triangle ABD. To calculate the length of the adjacent, you must go by TOA. And what does TOA says? TOA says that the tan of the acute angle here, which is 30 degrees, must be equal to the length of the opposite. So in this case, the height of the lighthouse becomes the opposite. It was giving us 90 divided by the length of the adjacent. In this case, the length of the adjacent, we are looking at line AB, which is represented as x. So let's solve for x. So tan 30 is the same as tan 30 on 1. We can cross multiply. So tan 30 times x, that should give us x tan 30, and then 1 times 90, that should give us 90. We are looking for x, so we divide both sides by tan 30. Tan 30, so tan 30 will cancel out. So x is equal to, so what is 90 divided by tan 30 from our calculator? 90 divided by tan 30. So to two decimal places, I'm having 155.5 0.88 meters. So that is for x. Now again, let's also calculate the distance from point B to point C. In this case, the distance y. So in this case, we have to use the second right angle triangle. So from triangle, so we named it as triangle BCD. BCD. So now, this side here becomes the hypotenuse. And then this side here still remains the opposite. That is the height of the lighthouse, because this height here represents the acute angle. And then obviously the remaining side here represents the adjacent. So it means that to calculate the length of the adjacent, we have to consider the opposite and then adjacent. And using SOHCAHTOA, we see that TOA has opposite adjacent. So again, from this second right angle triangle, that is triangle BCD, the tan of the acute angle, which is 45, is equal to the length of the opposite, which is also the height of the tower, divided by the length of, or the distance between point B and then C, represented as y. We are looking for y, so we can cross multiply. Y times tan 45, that should give us y tan 45, and then 1 times 90 should give us 90. We are looking for y, so we can divide both sides by tan 45 here by tan 45. So tan 45 will cancel out, leaving y is equal to. So from our calculator, what is 90 divided by tan 45? So that is giving me 90 meters. So now, what is the distance between the two ships? The distance between the two ships. So you are looking at the distance from point A to point C. So you could see that it has been split into two. One part measuring x and then the other part measuring y. So the distance between the two ships will be the sum of x and then y. So the distance between the two ships, becomes distance between the two ships becomes 155.88 meters plus 90 meters, and that should give us 155.88 plus 90. That should give us 245.88 meters. So that is the distance between the two ships. Thanks for watching.